So what we're looking at here is integrating a composite function, all right? And in derivatives, we had the chain rule, okay? With integrals, we have a process called U substitution. It's more of a whole process that you have to go through to integrate stuff for composite functions. But this special case here, where the inner function is linear, we can handle really simply, and we don't need to really use the entire process, even though we could, okay? So you'll notice here we have a function where it's an outer function f of something, but the something is linear, ax plus b, okay? And you can see here, if we have a composite of a linear function ax plus b, the integral of f of ax plus b dx is 1 over a times the antiderivative plus c. Now, notice here the antiderivative still has that ax plus b in it. This is a parallel to when we did the chain rule in derivatives, okay? Because when you did the chain rule in derivatives, when you took the derivative of the outer function, the inside stayed the same. Here, we're going to take the integral of the outer function, and we're going to leave the inside the same. Okay? The only difference here is that we're going to multiply by 1 over a. Now, the question is, what is a? If you notice here, for the linear function, a is the slope, or something that will help us tie this to U substitution later, a is the derivative of that linear function. We know that the slope is the derivative, okay? So it is related to derivative here, and we're multiplying by 1 over a. Okay? So, as we look at this first example here, we have the integral of 1 over the square root of 1 minus 2x dx. So, starting out, if I had just given you, say, the integral of 1 over the square root of y dy, okay? All right, the first thing that you would probably do here is rewrite this 1 over square root of y as y to the negative 1/2. Okay? So we're taking the integral of y to the negative 1/2 dy. Yes. Well, I'm just saying a parallel example here. Let's say we didn't have the 1 minus 2x, it was just the square root of something else. Yeah. Okay? If I were doing this, we could just use our rule for x to a power, okay? Or something to a power. We'd add 1 to the exponent, so now it's y to the positive 1/2, and then we would divide by the new exponent, so divided by 1/2 is times 2, so we'd have 2y to the 1/2 plus c. Okay? Now, we're going to do something very similar to that with this, okay? We're going to take, instead of a y, let's get rid of this here. Okay. Instead of a y, we're going to use this 1 minus 2x to the negative 1/2. And it is going to be 1 minus 2x to the positive 1/2 times 2. But according to our rule, because this is a composite function, and because the inside function is linear, we're going to take the derivative of that inner function. What is our derivative of the inner function here?
2.
Negative 2. And we're going to multiply by 1 over that negative 2. So it's negative, or 1 over negative 2 times all of that. Okay?
So because the derivative of the inner function is 2, that's why we put 2 for a negative 2. That's why we put negative 2 for a.
Yeah, that's why we put negative 2 for a. So we're multiplying by the 1 over negative 2. And then there's some simplifying. We can simplify this down to a negative 1 minus 2x to the 1/2, or negative square root of 1 minus 2x plus c.
Why is it negative? Oh, because it was negative 2. Okay, never mind.
Yeah.
Fine.
Okay. All right, so in our second example, we have these natural exponential functions, okay? Now, as you're doing these, at least in your head, this is kind of how you need to think of this. We have a constant multiple, and we have two functions being subtracted. So we can think of this as 2 times the integral of e to the 2x dx minus the integral of e to the negative 3x dx. Okay? You don't have to write this out necessarily, but this is at least what should be going through your head. You're breaking it down and seeing it as separate pieces. Okay? So, if I'm taking the integral of e to a power, what does that equal?
E to the power of time.
Yeah, the integral of e to a power is e to a power. Okay? But because our power is this linear function 2x, what do I have to do?
Wait a second. We divide and multiply by 2 because of the integral.
Well, you're multiplying by 1 over a. Okay? What would a be in this case?
1 over 2.
It'd be 2, so we're going to multiply by the 1 over 2. Okay? The derivative of 2x is 2, so we're multiplying by 1 over 2. That's where this 1 over a comes in. Did you?
Yeah. Well, I mean, I guess in this situation it's just like an easy example, but you could already see that it would just be e to the 2x, because if you look at it the other way around, when you take the derivative of e, you do also the derivative of the exponent. So that would be 2. So really it would just be, I don't know if that made sense, but it makes sense.
No, and actually you're kind of, because you've done a little u substitution,
Yeah.
you're kind of seeing that in your head, and that's
Yeah.
good. That's good. Alright, so now we have to handle this e to the negative 3x. So it's minus the integral of e to a power is that, okay? So it's e to the negative 3x. But since we had that negative 3x, the linear exponent, how do we handle it?
Negative 1 over 3.
Very good. We're going to multiply by a negative 1/3. Okay? So we do a little bit of simplifying here. The 2 and the half cancel out, so it's just e to the 2x. The two negatives will cancel, so it'll be a plus 1/3 e to the negative 3x. And we'll throw in the plus c there too. Okay. Any questions?
Mr. Dixon, have you seen, do you watch SNL?
Alright, so let's look at this one here with some trig functions here. We've got 2 sine of 3x plus cosine of 4x plus pi. We're going to integrate this with respect to x. Okay? So we've got 2 times the integral of sine of 3x. So what's the integral of sine? Good, negative cosine. So negative cosine, and it's going to be negative cosine of what?
3x.
Of the 3x. It's still going to be of 3x. Okay?
Do we do 1 over times 1 over 3?
We do, okay? Since we're taking the cosine of 3x, there's a linear function inside. We're multiplying by 1 over 3. Okay? The derivative of 3x is 3, so we're multiplying by 1 over 3. Okay? Now we have plus the integral of cosine of 4x plus pi. So what's the integral of cosine? Positive sine. Okay, it's positive sine. Okay, remember we have sine, cosine, negative cosine. This way is taking the derivative. This way is taking the integral.
Is 1 over 4?
Okay, so yeah, it's the sine of the 4x plus pi, that stays the same, and it's times 1 over 4, because the derivative of 4x plus pi is just 4. So it's times 1 over 4. Okay? We simplify a little bit, we get a negative 2/3 cosine of 3x plus 1/4 sine of 4x plus pi plus c. Okay? By the way, on these ones especially, I would make sure that I put parentheses around what's inside the cosine and what's inside the sine, just so there's no confusion. Oh wait, was that a cosine of 3x plus 1/4, or, what is that? So just put your parentheses around it to make sure it's really clear. And you really need to put parentheses around the 4x plus pi. Otherwise, it really just says sine of 4x. Okay? Alright? Now, one of the things that we have to do in integration is that when we're dealing with trig functions, there are a lot of things that we actually can't integrate as they are. Okay? For example, if I were trying to find the integral of 2 minus the sine of x quantity squared, okay, the first thing we might do is FOIL that out. Okay, so we have a 4 minus 4 sine x, okay, plus sine squared x. And we could take the integral of 4, that's just 4x. We could take the integral of negative 4 sine. The integral of sine is negative cosine, so that'd be a plus 4 cosine x. But the problem is, we don't have a rule for the integral of sine squared, okay? We don't have a way to integrate a composite function like this one, where the outer function is something squared, the inner function is not linear, it's sine. Okay? So you'll notice here it says use the identity sine squared equals 1/2 minus 1/2 cosine of 2x. Now I'd say, well, how in the world do we get that? Well, in this case we're given it. And on the IB exam, this would be a perfect example of the type of thing they might do as a two-part problem. They might say, show that sine squared equals 1/2 minus 1/2 cosine of 2x, and then hence, the second part would be hence, find the integral of 2 minus sine quantity squared. Okay? Now, if we were asked to show this, we see this cosine of 2x. Remember, when you're trying to verify an identity or prove something, we'll typically start with the more complicated side. So I would start with the 1/2 minus 1/2, and I'd look at that cosine of 2x, and I've got to get sine squared out of it. And if you remember from last year, and it's also in the formula booklet, you've got identities for cosine of 2x. So it could equal cosine squared minus sine squared. It could equal 2 cosine squared minus 1. Or, the one we're going to use, is it's 1 minus 2 sine squared of x. Okay? Now, if I distribute the 1/2, I now have 1/2 minus 1/2 plus sine squared. The halves cancel out, and that just equals sine squared. Okay, so a little bit of review from last year, verifying a trig identity. Start with the more complicated side. Don't use algebra, like don't multiply both sides by 2 to get rid of the halves or anything like that. But you just gotta work with the one side until it looks exactly like the other. Okay? So now that we know that, instead of finding the integral of sine squared, we can take the integral of 1/2 minus 1/2 cosine of 2x dx. Okay?
I'm sorry, for the 1/2 minus 1/2, how do you start with that if it's not
They give
given
it
to you?
That's a good question.
Do we know
If-
that, or should I just?
Well, here's the thing. If we were doing this problem and we got to here and we were not told this, you'd have to do some creative stuff to try to get from here to like this.
On the like test,
Um,
would it usually be given?
Usually for like IB level stuff, they would probably give you something like this and say, show that this is true first, so you're doing this, and then use it down here.
Do we have
Okay.
that in our formula booklet?
The cosine of 2x? Yes. This identity is not in there, but the cosine of 2x equals this is in there. Okay? And that's the thing with integrals, it's actually pretty complicated. Doing these complex and especially trig functions, you know, you got to get really creative with the identities to try to get it down into pieces that you're actually able to integrate. Okay? And in fact, there are some where we just can't, and then you have to use other strategies, like there's a trapezoid method using sums and all that kind of thing. So, you know, it can get really complex. So we're dealing with SL, we're dealing with a kind of a basic level of integrals. And that's why they would give us, like, show the identity as true first and then use it later, okay? But now that we've got it, we can take the integral, it'd be 1/2 x minus 1/2 cosine of 2x. What's the integral of cosine? Sine, so it's sine of 2x times 1/2. There we go. We've got to take care of that 2x inside. Alright, so we have 4x plus 4 cosine of x plus 1/2 x minus 1/4 sine of 2x. I'll put the x's together, so I've got 4.5 x plus 4 cosine x minus 1/4 sine of 2x plus c. Okay?
I hate trig. I hate it. I hate it.
Yeah.
I thought you loved it.